So leading this entire discussion, we've been saying that we want to know our types. We want to use a coding style that makes our types more obvious. And up to this point, I've been using only what we know about JavaScript to do that. I've been suggesting that we can restrict the kinds of values that can come in for type comparisons, for example. And I think that is a valid and worthwhile approach that will improve the quality of your code, regardless of whether you like or dislike the current trend towards these typing systems like TypeScript and Flow. And I'm going to say in a broader category, type-aware linting. As we said earlier, linting is essentially a tool that applies an opinion about your code and gives you that opinion so that you can decide, you know what, I agree, I shouldn't do that. My linter catches all kinds of things that I don't want to do, and I'm glad my linter catches it. I'm very much pro the idea of linting. As I said, I'm only pro linting that is configurable, however, because there is not a one-size-fits-all. Now, I'm not in the situation like many of you are where you're on a team. But even with respect to making that decision, you should still be able to have the team decide democratically rather than the team only be able to pick what every other team in the entire world has done. It's still better that the team could decide what works for them and that the individual members of the team get to have a say-so in what that is. We call that style guides. That's an old school term. Your team needs a style guide, and everybody should have a vote in the style guide. I don't like it when I go and work with a team and there's some like benevolent dictator on the team that has made all the decisions for everybody, and people come up to me like during the breaks and like, I'm scared to try this because he's going to reject my pull request. That's not a healthy culture. Everybody should get a say-so in what works for your team. Not me. You and your team members should get the say. So, broadly speaking, I get a lot of times this question of, what do you think about TypeScript? Well, what I think about TypeScript and what I think about Flow are similar, which is I'm glad that they exist even though I don't use them. I don't use TypeScript and I don't use Flow. And I used to tell people the reason I don't do that is because they solve problems that I don't have. I have a different perspective on that now, a perspective that has evolved recently. It is not the case that I don't use them because I don't have the same problems that they solve. That's not the appropriate way to say it. I don't use those tools or don't prefer those tools because they are fixing the problems in a way that I think makes my code worse. Problems exist. As I've said over and over again in this unit of our discussion, it is a problem if you are coding and not knowing anything about your types. That is a problem, and we should solve that problem. It's just that I have a different opinion on how to solve it. You with me? So before I talk to you about a solution, let's look at what TypeScript and Flow can do for us. What are their benefits, broadly speaking? I understand that this is a very sort of reduced argument. There is a much more complex and vivid ecosystem, and I don't mean in any way to talk down about these. There's a whole course on Front-End Masters about, or maybe even more than one, about TypeScript. These are great tools with fantastic, intelligent people behind them. But just sort of broadly speaking, where do they fit within the ecosystem? What are they going to do for us? Well, number one, they are going to catch type-related mistakes. That's a good thing. We need help catching our type-related mistakes. I would like to have a tool that understood what I want to do with types and helped me figure out when I didn't do that correctly. That would make me a better coder. Number two, they do communicate type intent because the typing is in the code. Of course, they have modes where they are doing only inference, but essentially the big selling point of TypeScript and Flow is that you can layer these annotations, these type annotations, directly on top of the code. And that, in some respects, one of the biggest reasons why you do that is because it's going to make your code more obvious. Well, I can clearly see that that thing is an integer or that thing is a string, right? That's good. Number three, and I think this is often overlooked, but maybe one of the biggest things, is that by doing so, by choosing to opt into that system, you get an amazing amount of feedback through the tooling ecosystem that can show up live directly in your IDE. It's awesome. I've seen some of the auto-completing and on-the-fly, inference and type analysis that something like TypeScript does. TypeScript does it a lot better than Flow at this point, but I'm sure Flow will catch up, right? I think IDE integration with TypeScript is better than any project that I've ever seen integrated in an IDE. It's fantastic. I happen to not use IDEs, so I happen to not benefit from any of that, but that doesn't mean I don't respect it. I think it's fantastic. There are some caveats to these tools. Number one, the inferencing that you rely upon, which you rely upon inferencing whenever you have a place where you're not going to annotate. The inferencing that you rely on really is just a best guess. It's not rock solid. We're guessing something as much as we can at compile time. We don't really know what's actually going to happen at runtime. That flows from number two, actually, because the annotations are optional, which means the developers on your team, if they don't put an annotation on a variable, TypeScript, will default to the any type, unless you have that turned off. It'll default to the any type, and then you're not getting any benefit out of it. So it is an opt-in system. And if you don't opt in a particular place, you're only getting a best guess. It can lead to a false sense of security if you're not being very careful about your usage of it. This flows from really what I've been saying the whole time, that any place that isn't typed, either in your code or things that your code touches that are not in your application, if they aren't typed, there is uncertainty. So they can only go so far. They can tell you what we can tell you at compile time, but they can't really tell you anything about what's going to happen in the real world. They're just going to hope that none of that bites you. So some examples of TypeScript and Flow, and these examples are actually identical between the two. They use identical syntax in these cases. There are a few little nuanced differences, but I was actually remarkably surprised in my research for this preparation how similar TypeScript and Flow are in terms of what they look like. I expected a lot of differences, and they're very few. Okay? So number one, if you don't do any typing at all, both TypeScript and Flow by default will do some inferencing. So here, they're doing a static types inference, which means that my intent that they're guessing is that I want teacher, the variable, to only ever hold strings, and when I later try to assign it something non-string, it throws me an error and says, you're doing an assignment that you shouldn't do. That's their best guess. Some people feel that one of the biggest problems within types is that we accidentally assign a value to a variable that is not the type we thought. And so for them, static types are a big deal. I'm being honest with you when I tell you that in my 20 plus years of coding, never once, not once, has a bug been as a result of me accidentally assigning a number to a variable that used to hold a string, for example. I do that on purpose a lot, but never once has that accidentally happened and been the source of a bug. So for me, that's not one of the problems that I have. If it is a problem that you have, where bugs come because you've reassigned something incorrectly, this is helpful. This is one of those features that for a long time I said, I don't need that part of TypeScript. I don't like for it to complain to me about what I assign variables, because I like to be able to assign a number and then later a string. That to me is helpful. So I didn't like this part, and I felt like it was solving a problem I didn't have. But that's what we refer to as static types, inferring that the variable has a type based upon the value that goes into it. JavaScript variables don't have types, but we're layering on this extra requirement, if you will. Okay? So that's when we don't annotate the types, but of course we can annotate the types. We can say teacher is definitely a string. We're going to get basically the same error, but here we're not guessing at the error. We're literally saying, I intended for this thing to only ever hold strings, and now you're trying to put something non-string into it. In both cases, TypeScript and Flow are going to throw us an error and say, you're assigning something you shouldn't have. Okay? Great. We can get much more sophisticated when we talk about function parameters and return values. You can define custom types like this. Here I'm defining that an object of a type that has a property called name that is of type string, that is a type, and then I can pass values of that type as parameters, and I can receive values back as parameters. So here I am passing in student rec of the type student. I'm defining my own type, if you will. So it's much more powerful in that you can define these custom types. And this program, just to be clear, this program doesn't have any errors because what it knows is that when I do line 4, a return of studentrec.name, it knows that studentrec was an object with a name property that was a string, so it knows it's returning a string. And when line 9 I try to assign it to a string, it knows everything's fine. But you'll notice that most of the guarantee here is all about, are things being assigned correctly? Are they being assigned the right types? A parameter to a function is a lot like a variable. If you're saying, I want to only be able to pass in numbers, then you're basically saying the same thing as, I want this variable to only hold numbers. Were I to use something like TypeScript, I probably would define many more of my parameters as, say, union types. Where I would say, you know what, I'm going to allow strings, numbers, and nulls. Because it's rare that I want it to be so restrictive that it can only ever receive exactly this kind of structured object, for example. But nevertheless, it's able to do some very useful guarantees if the problems that you have are misassignments of types. One thing that I think is undervalued within TypeScript, this is actually where many more of my bugs have come from, is that in addition to being able to tell us static typing information about variable assignments, it can also tell us that certain operations would be invalid. In this particular case, it's saying you can't subtract a string from a number because that particular preference is saying don't allow that coercion. And in this particular case, that would be a really useful help for me. I would really like for a linter to tell me don't try to subtract a string from a number. What I'd really like is a linter that let me have that, but not let me have all the complaints about my static type assignments. That would be my preference. But this is, I think, an undervalued part of what they do, is that they are actually allowing us to check the operations that we're doing, where most of our business logic is, and making sure that those operations are valid. It would be nice if TypeScript would have some mechanism by which you could allow some more coercion to occur, because there are plenty of places, as I've already made the case, where I'd like to be able to do coercion, and other places I'd like to avoid it. It appears to me in my research that TypeScript is kind of all or nothing. You opt into it or you don't opt into it. I would prefer there to be more nuance in configuration. If you're curious about TypeScript and Flow and their differences, this is both similarities and differences, but especially differences. I found this particular article to be very helpful. They went through essentially both projects side by side, big long list of all the different characteristics and where they are the same, and the places where they're different. It's a good article, so I'd recommend checking that out. In summary, what I would say is that TypeScript and Flow are very useful in that a lot of people are finding them to be helpful to solve their typing issues, helpful to make their types more obvious. Where I find them to be frustrating, or maybe it's just me frustrated about the ecosystem, is that we seem to jump immediately to that's the only option. If you have types, you can either ignore types entirely and use triple equals, or you can jump to this other extreme, which is layer on something on top of JavaScript, which I would argue is fundamentally not really the DNA of JavaScript. And I would like for there to be something in between. So to understand that thing that I would like there to be in the middle, the all or nothing sort of conundrum that we're facing, I want to dig into those pros and cons a little bit more specifically. These are just my takes on the pros and cons. This is not some objective list. Number one, I think one of the big pros about systems like TypeScript and Flow, I said this earlier, they make the types much more obvious in your code. And that's a big improvement. A big improvement over writing code that's essentially completely uncertain, unascertainable what's going to happen with this particular operation. Making those types obvious is a good thing. It's also a very strong positive that the design of TypeScript and Flow goes with the, to put a pun here, goes with the flow, if you will, of the way static typing works in a lot of other languages. The syntaxes are very similar, and so there's a strong sense of familiarity. When you show up to something like that, you're not in this entirely different world than you've ever done with types before. It feels very much like the types that you have from a more typically typed language like a Java or a C++. So the familiarity is a strong pro, and I'm sure that was part of their design. They are extremely popular. It's undeniable, the popularity, especially of TypeScript. It seems like every day we get an announcement of some new major open source project that's completely converting over to TypeScript. And just like the hype curves that build up in the community behind something like a React or a Vue, they've built up in such a strong way with a big backing, TypeScript being from Microsoft, Flow being from Facebook. They've built up in such a big way with the community and the corporate support behind it that the investment to learn and get into one of those is going to be an investment that pays off for a long time. It's not some fad that's going to go away next week. So the popularity is a strong suit. There's a big community behind it, a ton of documentation, a ton of momentum behind these projects, and it certainly does make sense. In fact, I would absolutely say, whether I liked TypeScript or not, it would be silly to me for you to be working in a system, say you worked in a Microsoft.NET shop, and you wrote C# all day on the back end, and then you needed to do some JavaScript. I can't imagine a scenario where you wouldn't use TypeScript, because the mental context switching of I've been in types world and now I'm in non-types world would be nuts to me. So there's lots of scenarios where it makes complete sense, and the popularity of that's the reason why it's growing. And they're very sophisticated, and that makes them really good at what they do. I'm actually kind of amazed at how much something like TypeScript or Flow can infer from code that I even intentionally try to obfuscate, and they're still able to figure those things out. These tools are fantastic at that. So these are all strong pros, but I also have some strong negatives against them. I guess my biggest negative is that they chose to use a syntax that they had to layer on top of JavaScript. And someday, maybe, JavaScript standardizes this syntax in it. What they've had to do is essentially go and define an external standard for it. It's not that there is no spec, but it's an external standard, not a JavaScript standard. And there's certainly no guarantee or even likelihood at this point that what we see in TypeScript or Flow is exactly what might end up in some hypothetical JavaScript. But it is years away. It's not like we have a stage 3 proposal to add typing to JavaScript at any point soon. This is way far out if it ever happens. And I think it creates a sort of ecosystem lock-in. Whenever you choose a particular syntax and a particular kind of tooling that isn't portable because it isn't the same as what JavaScript is. JavaScript, one, because it's so ubiquitous, but then now we're locking ourselves into this ecosystem that, even though it's popular, is not necessarily as ubiquitous. And so I guess that's one of my biggest frustrations or my biggest hesitations. Now, it is true that I was actually very pleased when I saw that these tools came out with a way that you can do their typing annotations using only code comments. So at least in that scenario, you haven't locked yourself into, if I don't use this tool, this code literally can't run. Right? That's sort of an escape valve, if you will. And that's a good thing. But almost nobody's using the code comments. Everybody's using the inline syntax annotations. And so there is a lot of lock-in that happens. And I guess I've been around long enough to be wary of those sorts of lock-ins. Another thing, and I've got an asterisk here on purpose, but essentially using those tools requires a build process, which kind of raises the barrier to entry. And the only reason that you wouldn't be required to have the build process is if you did that code comments approach and then got no benefit from the system whatsoever. So nobody would do that. Nobody would go to all the trouble to write all those code comments and then not use the tool at all in the compiler and then ship it directly. So they're essentially requiring this build process. And build processes are definitely common these days. But again, as an old schooler, it's nice to just be able to write a JavaScript file and load it directly into a page without having the complexity of a dozen tools in some particular pipeline. And so I'm not a big fan of us saying to future developers that want to learn JavaScript, oh, by the way, you also have to learn all this DevOps-y stuff just to write your first line of JavaScript. If TypeScript represented what I hoped the future of JavaScript would be, what bothers me is that TypeScript is done in such a way that they're going to be locked into that build process forever. And I don't think that's great as a barrier to entry. Kind of flowing from that same discussion would be that there is a trade-off when you make really sophisticated tools, is that you create a surface area which gets complex very quickly. The difference between the examples that I showed, which were just some sort of basic layered on types, and when you start layering in things like generics and interfaces and other things like that, you rapidly get to a style of code that doesn't look even remotely like JavaScript. It looks like Haskell, in my estimation. And I don't mean that like in a sort of like, I don't mean that in a way to say TypeScript's bad because that's the case, but that is very intimidating. I mean, I'm spending time and lots of mental effort here trying to, in the research for this course, trying to figure this stuff out, and I start reading through some of the advanced features of this, and I just got completely lost with all these angle brackets nested all over the place and stuff. The syntax explodes exponentially in complexity. And I think if anyone were using those sophisticated features, I cannot imagine them hiring a developer on that was not already a very strong TypeScript developer, and them having any clue what to do with the code base. So again, that barrier to entry ramps up very quickly as you start to use more and more of that tool. And I guess maybe the final frustration that I have, or the difference that I share with these tools, is that I don't think it's in the DNA of JavaScript to consider the idea of static typing. That is, that containers, things like variables and parameters and returns and properties, that they necessarily must only have one type always and forever. There can be some places where that's beneficial, like the return type of a function. But variables, I guess specifically, I don't think that's within the DNA to type our variables. If you think about what JavaScript really is, and in fact any dynamic language, it's a language that is value typing, not variable typing. And so this feels like the wrong thing foisted on top of JavaScript. It feels fundamentally to me like it's not, it's a betrayal. It's not respecting the way JavaScript works. It's trying to make it into something different. And some people are trying to make it into something different because they think what JavaScript currently is insufficient, that it's broken, that it's not good enough. I think JavaScript is fantastic. So I don't think we need to fix JavaScript. That, I think, is probably one of the strongest cons. So there's a big divide there between the great things that this tooling can do for the ecosystem and for the teams that are using it, and I think some really strong downsides, and there should be more options in between. And it's why I started this discussion by saying I want to broaden the discussion from just specifically these two trademarks like TypeScript and Flow to a larger discussion about the idea of type-aware linting. That type-aware linting as an idea is useful and important, and TypeScript and Flow are two particular ways of doing it, but not the only ways of doing it. So wrapping up our whole discussion on types and coercion, wrapping up this unit, let me make some final observations. Number one, it is true, it is a fact that JavaScript has a dynamic type system. It is a type system, it just is dynamic. I really bristle when people say JavaScript has no types. It definitely does. It's a type system, it's just not Java's type system. It uses various forms of coercion, but they're for value type conversions rather than variable typing. And we also have equality comparisons that can be coerced. The prevailing response to JavaScript's type system is essentially avoid as much of the system as possible and only use the triple equals to protect yourself so that you don't have to worry about that. As I've said several times now, I don't think that that is an effective strategy. Part of the problem with avoidance of anything, but especially an entire unit of the language like that, is that it tends to systematically perpetuate bugs. That is to say, it's not that one bug will happen or one bug won't happen, but the mindset that says, I don't even need to understand this whole part of the language perpetuates bugs. That's a systematic approach. And I would never recommend a systematic avoidance of any particular thing. That is, avoidance of even understanding it. What this boils down to is that I just believe that you cannot write quality JavaScript programs without understanding your types. You can write JavaScript programs that ship and run, but they don't meet that bar of what I think we should be striving for in quality unless you understand those types and unless the readers of your code can understand those types. So we have to do something. We've got to change the way we structure our code. We've got to use these mechanisms that are available to us to start signaling those typing things. And of course, you could go all the way to using a whole static type system, like a TypeScript or a Flow. And if that's your answer, I'm not going to beat you up. Right? Like that's okay, and that makes sense for a lot of teams. But I do think that there's a way to embrace that, because I really think that's almost an avoidance of the issue as well. It's a different kind of avoidance. You're basically saying JavaScript system is hopeless, so let's build a whole new system. That's a different kind of avoidance, and I'm not sure that it's healthy. So I don't think JavaScript's types are inferior. I think they can be learned and leveraged, and I don't think it's that much more difficult. In fact, I think it's less difficult for you to learn this system taught properly than to go learn all the complexities of a static type system. I mean, thinking about all the sophistication in TypeScript, I would consider that to be a very daunting task. And I think what I'm trying to discuss here is a much simpler and smaller thing to learn. So my claim is that really the better approach is to embrace JavaScript's types and adopt the coding style which goes with that grain, that makes those things obvious. You are going to have better code as a result. By thinking about those things, you are going to structure your code better. That's almost undebatable. That if you think about your code better and you think about your types and you design things so that you understand what they're doing, you'll end up designing better code, and that code will be more robust. It'll have fewer bugs. And that's if you do nothing with the double equals. Just think about your types, right? You don't even have to use the double equals to get that benefit. So if you hear nothing else about me, at least from me on this unit, at least hear that. You should be striving for that in your code. I think you can optionally choose to use other approaches, and maybe Typal is one of several that could begin to exist in the ecosystem that give other options besides these extremes. So hopefully that is going to open some different avenues of analysis. Really, that's all I ask, is that you go back and think about those things, test out the assertions that I'm making, and see if they make sense for you and for your code. But I'm quite confident that your code quality will suffer if you persist in the I don't need to know types. Right? Triple equals is all I ever need. I just don't think that's better code. So hopefully I've given you some food for thought. That is it for the types and coercion unit of our course.